Hello and welcome back. So in this video, we would want to practice the functions we did or we learned in the previous video and then combine it with some other things that we've learned so far. So the goal of this video is to see whether we can use our knowledge so far to create some basic math functions that we can easily use, right? So it's very simple. The first one we will do is to see whether we can write a function to represent a constant pi that we can always use. The second one will be to write our own sine function, our own cos function, or cosine function, and then tangent function. And then to crown it all, we would want to also write a function that will determine the nature of roots that a quadratic equation would have, right? So when you give it, if you give in any quadratic equation, the function or should be able to know that, oh, this equation you've given me would have a complex root or a repeated root or a unique root. So without wasting much time, let's get started. All right, so first things first, if you can take this upon yourself as a challenge, pause this video, try and see whether you can do these things from the knowledge you've gained so far. And if you can't, then you watch. After watching, I recommend you pause and you practice, you redo them on your own. Practice makes permanent. Okay, so to create the function, so let's do, so touch, okay, let me use my create function, the create script dot forward slash create. So now I want to do trig func dot sh. So it has to create a function for me and then make it executable. Okay. So now I can access the trig func. Where are you? Here. Okay. So now I have the trigonometric script here, and all I have to do now is to see how best we can do it. So the first activity is to get the constant pi. So pi constant. So now, so far you've seen that we haven't actually seen any mathematical way to get the constant pi, right? So let's see how best we can do to get the constant pi out of the functions that we know how to create. So to begin, we said that we would have to create a function by giving a function name. So I want to call it capital Pi. That's pi. That's to represent as a constant. Then this is just a constant function. So what I would want it to do is to compute a certain value for me. Now, one smart way to get the value of pi is just to, we know that tan inverse of 1 is what? 1 over 4 pi, or pi over 4, right? So if I can multiply tan inverse by 4, it means I can get the value of pi, right? So this one I would use the BC utility. So by then I echo the math that I want, and before then I want it to give me pi to, okay, for now let's just do it. So 4 times, we said to get the arctangent is a, right? But then we want arctangent of 1, so arctan of 1, this would give me arctan of 1, and then we pipe this to the basic calculator. But if you want to make use of the arctan and the others, then you have to pass the dash L option here. So this would make this one here give us the arctan, right? But then if you multiply by 4, we expect it to give us an approximate value of pi, right? So let's try running this script, dash forward slash break func sh. Okay, so now this has been created, but then we haven't called our function. So to call our function, we just call capital Pi, and then let's see. Okay, so this value here is a little bit closer to the value of pi, but this is fine, right? So now the question is, how then do we use this pi value in our work, right? So if you want to assign this value to any variable so you can use in any code, you can always do that by just saying that, let's say my small pi variable should be equal to dollar parenthesis of capital Pi. So if I do this and I run this, sorry, let me comment out this. If I run this, I don't expect to see any output. But when I echo the small pi variable, I should get what? The value of pi. So now we've been able to create a function that would give us a value of pi, right? So this is my pi constant, has been created successfully. So now that we have our pi constant here, the next thing we do is to see whether we can get our sine function. So sine function. So for the sine function, you can pause the video and try it out and see. So for the sine function, I do sine, the name of the function. We could decide to call it sine so that everybody can actually see sine. But then you can give it any name at all you want, right? So, okay, let's just follow the conversion, sine, and then now inside the curly braces, you put the math command, right? But this time around, I wouldn't use BC, I want to use the awk, right? So I can say awk, and then after the awk command, we know that we bring quotes, and then inside the quotes, we decide to do what? We begin, right? So begin, and then in your curly braces, you print whatever you want to do, right? So here, I want sine of any value, but then it means that we need sine of anything or sine of something, right? Which means that we have to pass the argument. This has to receive an argument. So we want sine of $1, right? So you call the sine function, you pass an argument, the first argument becomes your $1. If you can either do it this way or you create a new local variable called maybe x, and then you assign that to $1, and then here you call your x inside the sine function. This should also work. So now that we've created this one here, let's see if I call sine of pi, right? The sine of pi, we expect to get 0 or something closer to 0. So let's run this code and see. Wow, this is nice. This is 0.000, like 16 zeros before this. So this is very close, like very close to 0. Okay, so this works. So it seems that this code works, right? And in the same vein, if you want to store this value somewhere, you can just call your, let's say, answer, and then assign it to dollar of the execution of sine of pi, right? And then you get that, right? So you can decide to echo answer, and then you can decide to echo answer, and then you get the same value as we did by just calling the sine function. So basically this is it. We've been able to create our sine function. Can you try for cosine? Well, let me just copy and then do some editing here. So this one is for cosine function. So the cosine function is also similar. I'll just call this cos. And then I'm going to use awk. So here I change the sign to what? Cos. Bear in mind that we are still using the same. This is a local variable, which means it can never be used outside this function a. My cos function has been changed to constant. SMO. So now I have this. So from here, I can just call my cos function here and then pass the pi constant that I did. Right. So let's even try and see whether we can call the pi function here straightforward and see. If I run this code, wow, this is nice, right? This is nice. So cos of the pi, the straightforward pi gives me this 1. Cos pi is 1, right? So what if I do cos of the dollar pi? Should still be the same answer. Interesting. So we get 2 different values for pi. So we see that one gives us +1 and the other gives us -1. And then cos of pi is negative. So I think we first have to call the variable and store it before we work on it. Interesting. All right. So for some reason, I don't know how this is running, but well, that's the goal is to create a cos function and it's working well. So let's see whether we can find cos of 2 or 0. Cos 0 is what? Let's see, cos 0. Cos 0 is 1. And then this is -1. This is fine. And then cos 2 pi. So, okay. So now let me just leave the 0 there and then quickly go to the other one, the tan. So now from whatever we've done so far, can you pause the video and try out the tan? Or can you figure out how to do the tan or the tangents? So I expect you to pause the video and then try it out yourself. Okay. So basically the tangent is quite simple, just like the cos and sine, but just like this time around, we will just do a little bit more work, right? So you can do a little more work here. So you can choose to use the awk or the BC, right? So I declare my tan function and I said the tan should just be, so I can choose to use the awk or the BC, right? So I echo and then this echo I want to do S of something, the first argument that I would get over C of the first argument that I would get, right? So this takes, so it means that, or you can come here and reassign your first and second arguments by declaring a local variable x and then assigning it to $1 and changing this one's here to x here. But it should still work the same way. So we know that tan is the same as sine over cos. So you have that. So this is supposed to evaluate to give us tan. And then here, if I should pipe it to BC-L, hopefully if I call tan, it should tan of $pi should give me something nice, right? So if I rerun the script, I should get very close to 0. So basically this is it, right? So tan 1, I should get the same thing. So now you know the drill, right? So basically this is how we go about it. You can actually write your own functions to do some other other world mathematics stuff to represent quadratic equations and the other stuff. Okay, so I'm going to pause this video here. I don't want this video to be so long, so I will end here, and then in the next video we would look at how to build another one that would determine the nature of roots of any given quadratic equation. Thank you for watching. If you enjoy, don't forget to like, subscribe, and share with your friends so they will also learn something from this video. And I can't wait to see you in the next one. Thank you.